Students, today I will start a new lecture of non-linear system of Volterra's predator-prey equations. Yes, here everyone knows that there is a constant struggle for survival among different species of animals living in the same environment. One kind of animals survives by eating another species. So here we are developing developing a mathematical model for this. So we are developing a mathematical model for this process yes problems of these kinds of this kind have been studied by both mathematician and biologist. Yes. In discussing the interaction between foxes and rabbits. We take as the foxes eat rabbits. Yes. And rabbits eat clover. This is the source of food. And similarly, this is the source of food. source of food. Yes. And for this process, when the foxes become too numerous, when the foxes become too numerous and eat too many rabbits, then the rabbit's population declines. Then the rabbit's population declines. Yes. And as the foxes decreases in number, the rabbits become relatively safe. Yes. And the population start to increase again. Yes. As time goes on, we shape an endlessly repeating cycle of interrelated increase and decrease in the population of two species. That is, the size of the population X for rabbits and Y for foxes. Yes. Are plot Y for foxes. These are defined and plotted here in Y, X and Y. Y for the X for the rabbits and Y for the foxes are time related to the against the are plotted against time. So, if X is the number of rabbits, so if X is the number of rabbits at time t, then we have dx by dt proportional to x, that is dx by dt. This is equal to any constant ax. Yes, for a is greater than 0. Yes. As a consequence of unlimited supply of clover, if the number of y of the foxes is 0, so we assume that the number of encounters per time between the rabbits and the foxes are jointly proportional to x and y. Again, we assume that a certain proportion of these encounters results in a rabbit being eaten. Then we have dx. Yes, dx by dt is equal to ax minus bxy. Yes, wherefore a is greater than 0 and also b is greater than 0. Yes, in the same way we see, that in the absence of In the same way, we see that in the absence of rabbits, the foxes die out. Yes. And their increase depends on the number of encounters with rabbits. Thus we have, yes, dy by dt, this is equal to minus cy plus any other constant dxy. For all c and the constant d all are greater than 0. We have derived the following. We have derived the following non-linear system describing the interaction of the foxes and the rabbits yes, and therefore this is defined as dx by dt, which is defined as x time, yes, a minus by, and here from dy by dt, which is defined as dy by dt, which is here defined as minus y, taking here minus is y, then this becomes c minus dx. Yes, here you take y on both sides. Yes, let us suppose that this system is 1. Though the equation number 1, the equation 1 are called Volterra's predator, prey equations. Yes, prey equations. Yes, it means that is here you say that for a nonlinear system, yes, for this system there is a struggle for the two species, foxes and rabbits. We define a model like that, foxes, rabbits, and these are clovers, and for these we define those types of equation. Dx by dt is rate of change of this and rate of change of this. This is defined as this, and therefore this equation is known as Volterra's predator P equation. Yes, in the next video I have solved the equation number 1 and proved this system is stable. Okay, thank you.